Um, Hello, it's fantastic to present our work on crypto twin framework for the architecture, engineering, and construction industry. And essentially, the theme of the talk is enabling digital twins with blockchain technologies. We have been working on the combination of digital design, computational design, and models with blockchain technologies for the past 4 years with Davide, and this is part of kind of a wider work in terms of developing a model also of digital twins for architecture and how our current essentially development can help with that. I will go through some definitions. And then hopefully I will explain the structure of the crypto twin, and I would be happy to take any questions you might have. So what is it, essentially a digital twin, right? And why do we need one? These diagrams come from Michael Greaves, kind of like the let's say the father of digital twins. And a digital twin is essentially the kind of digital doppelganger of a physical entity. It is essentially a twin that exists only digitally, and we use this to make decisions about the physical asset. So this might be a product, this might be a manufacturing line, but it might also be obviously a building or a construction site. And the concept of the digital twin is that we use that as a model to make decisions because on digital space, those decisions are going to be cheaper and much more cost effective compared to actually simulating things in reality. And we obviously know this is a great concept for buildings because most buildings are normally virtually prototypes, right? They are not essentially part of a production line. The digital twin concept comes from manufacturing, actually, and it was intended to simulate essentially manufacturing processes rather than the finished article. However, the idea here and the context presented is on the level of not only constructing the architecture, but also so production of the architecture, but also the finished artifact itself and how we can govern it. There is always a question with digital twins in terms of whether you have a digital twin before the physical prototype, right? So could you actually understand that, for example, a digital model you might be building, is it a digital twin already, or do you have to wait for the physical prototype to exist? And you might, you as an architect, you might have your own kind of understanding of this. But the idea is that already when you are modeling something or when you are designing something, that is already potentially a digital twin, even if the physical instance has not yet been constructed. And if we try to understand the kind of life cycle of digital twins, or rather the scale of them, the most familiar part that we would have as architects is the digital twin prototype, right? So developing, for example, a building information model or any kind of model of how our architecture piece will be developed. Then, while the physical object gets constructed, that is essentially a digital twin instance that corresponds to a physical artifact. And then you might also get the digital twin aggregate, which is the corresponding digital twin for a collection of physical objects. So it might be, for example, imagine digital twins of singular buildings that get aggregated to a whole collection of a whole city. Now I will take a step a little bit and discuss blockchain. For those of you that are unfamiliar with this, blockchain networks are the ones that run cryptocurrencies. On a technical level, these are distributed computing networks that hold together a distributed ledger of transactions, and they also contain a software mechanism with which to decide what is truth in terms of those transactions and what is not. In a really simple kind of understanding, you can think of blockchains as ledgers that you can trust because of the nature with which they arrive at consensus using essentially incentives. I won't go too much into the depth of the technical aspects of blockchain from that point of view, because I'd like to focus on their next level, which is essentially smart contracts. And smart contracts are the software equivalent of an automated vending machine, right? So you have essentially software that can run on a blockchain, where instead of just doing addition and subtraction on a cryptocurrency, you can assign code that the whole blockchain network will execute. And from that point of view, you can develop software and computational artifacts that are trustworthy, and you can depend on them that they will behave the same way every time they get executed. And the kind of crux of the whole matter is that with smart contracts on blockchain, we have trust on the computer protocol. We have incentives. Normally, these might be financial or economic incentives, but they might also be incentives based on a wider ecosystem called crypto economics. And it is essentially also decentralized, so there is no barriers to entry, or you don't need to ask permission for someone to participate. Based on those smart contracts, you can design essentially economic utility, right? So you can design tokens. Easiest one to explain are obviously game tokens, in the same way you would have in a gaming arcade, right, where you would exchange fiat currency with a token that you would use to play games, or you might get essentially non-fungible tokens, so unique digital entities on the blockchain, which are created from cryptographically signing a digital entity, whether this is a model or an image or anything else like that. Now, previous work we have done essentially combines building information modeling with blockchain and allows a whole complement of collaboration scenarios to be run, where you can develop design problems that are going to be solved via collaboration through the blockchain, right? And we see here a really simple diagram where a decentralized infrastructure is used to coordinate designers attempting to solve a design problem, and through the blockchain and a decentralized file system, they synchronize their files and also the design solution, and then the system actually knows who has contributed and then shares funds between those designers. The next level of that is the kind of understanding of being able to build a whole collective that would be able to not only solve design problems, but also assign incentives essentially into problems that are normally currently solved through policy. So for example, we can assign a financial incentive on having a model that is going to be less wasteful and less carbon intensive. And through that point of view, the design team would earn more money the more carbon efficient and waste efficient their solutions could be, just as an example. This is part of a new book we have out with Davide Lombardi, Blockchain for Construction. And the kind of logical understanding after we built the logical conclusion after we built a whole collaboration suite on blockchain tools, as we're doing at the moment, is to develop essentially a digital twin tool set that runs on blockchain technology. So the name crypto twin obviously comes from the word cryptography and the underlying assumption that blockchain always needs to have to be trustworthy, needs to have really strong cryptography at its core, and that's how essentially it gets created as well. So you see really a simple conceptual diagram that we've developed by essentially going through a cycle of design science research, but also this was based on our previous work on combining BIM with blockchain technology. So on the left-hand side, you have the physical twin, which is devised by the physical structure, but also the IoT and the device. we can debate whether the user is part of the digital twin of the physical twin or not, right? So this is the physical structure plus the user, as you would see it here. The digital twin is on the right-hand side, and I'll explain the components so that we can have an informed discussion, right? So you essentially get the data model, the data and the model on what we call a decentralized repository, and this is based on the interplanetary file system. So this is a distributed internet file system where you find things not by address, but by the content identifier. So if you upload, for example, a model of the egg that we saw in the previous presentation, this would get assigned a unique hash with which you will find it. So if another user kind of tries to upload the same model, IPFS will already have it there. So within IPFS, we have the digital model of the building, the data logs, and a series of predictive analytics. And through this also, you can build a metaverse model to a bridge to whatever metaverse you might be using. We have an interface that basically deals with users of data from the IoT devices, but also authentication of those devices. And also the usage and actions of the users and authentication of those users. The core of the crypto twin is the smart contracts, which you can see here. And these are carefully structured in a way where you have essentially an IoT registry and a user registry, so you can keep track of who is related and what kind of data streams you have coming from the physical twin to the digital twin. You have a smart contract that decides, that makes decisions. So that's a governance smart contract. You have a treasury, right? So you can fund operations, and you have essentially another smart contract that will execute those operations. All of this is obviously logged and then connected with the digital model. The building information model is also developed into components, and these are essentially created into NFTs. And through that, you can have a one-to-one representation of the model within the smart contract. So that's the whole kind of idea of crypto twin. You can see here the kind of basis of how this is developed in detail. I'll skip a little bit forward so we can have more time for questions. And this was not part of the paper, but we have already been able to build the first crypto twin by developing with a collective we're part of called ArchiDAO and another decentralized autonomous organization called Norms One, a digital twin in the metaverse of Decentraland. And we were able essentially to use the digital twin, the crypto twin in the metaverse to change, to vote and change what kind of artwork would be displayed in the physical space. And I want to thank you for your attention.